this one I love the most. This is called the confusion matrix. And it looks probably confusing to you, but it basically says on the left is what the creature really is. And so let's pick PAR, which is paramecium. So I give it a paramecium, and 53% of the time it says it's a paramecium. This is what it guessed. But 31% of the time it says it's a blepharisma. So this is showing us that when you give it a paramecium, half the time it gets it right, but a third of the time it gets it wrong. And it tells you what it thinks it is. It says that it's confusing it with a blepharisma. It also tells you that when you look at a stentor, it 100% of the time guesses it's a stentor. And that was the largest creature, so you can see how that one's easy. But looking at this confusion matrix will tell you where your machine learning algorithm is messing up. And here we can see it's messing up with paramecium. It thinks it's a blepharisma. And there's a really important thing in doing data analysis. The mantra is know your data. I was working with a summer student. She just went back to Berkeley last week. We spent a lot of time trying to figure out a problem, and ultimately we aren't looking at the data close enough. And so I repeat this mantra, know your data well. And so here's the confusion matrix that's telling us that it's confusing paramecium with blepharisma. So let's look at the training set. The top is blepharisma and the bottom is paramecium. You own the best machine learning algorithm in the world. It's called your brain. So basically, a rule of thumb is if you can't with your eyes figure something out, it's going to be hard to make a machine learning algorithm to do it. And so I hope it's obvious to you why it's confusing blepharisma for paramecium. In some of the paramecium, especially when they eat, their stomach gets big. And that's what you're seeing here, the bulge. It's also orientation dependent. So on some views of the blepharisma, its stomach really shows. On some views, it doesn't. And that's why I was mentioning the bottle problem. Well, here's the problem with blepharisma. Some points of view makes it look very much like a paramecium. Now, quick solution. Anyone have an idea of how you can approach this problem to help solve it, to help disambiguate blepharisma from paramecium? I'll give you a hint. Remember, we have a movie. So here's the bottle. It definitely looks like a bottle. All of a sudden, it looks like a circle. But remember, it's a movie. We're continually tracking this thing.
Is it the movement?
Close. Something about it. If you take pictures of this, it's going to say bottle now, and then it's going to say circle here. Well, we know it's always a bottle. So basically, if you keep on looking at a trace, and it always says paramecium, then it's a paramecium. But if you're tracking it and it says paramecium, paramecium, blepharisma, blepharisma, paramecium, paramecium, then you know it's a blepharisma. Does that make sense? It will at the end of the term.